We're going to go ahead and take a look at graphing piecewise functions. Yes, piecewise. We actually have three different pieces here. We have three different functions depending upon your domain. The function is here. The domain is right here. So here we have another one with our domain, and then we have a third one with our domain. So we have three separate pieces. Sometimes piecewise functions meet up with each other when they go from one piece to another piece. Sometimes they do not. So the part that's after the if tells you your domain. So it says I need to try numbers that are less than or equal to -2. So I can try -2, -3, -4, and then that pattern would go on. So if I take a -2, plug it in here, -2 minus 3, plug in -3, -3 minus 3, -4, plug it in here, -4 minus 3 would be a -7. So all I'd have to do then is go ahead and plot those points. 2 over, 5 down. 3 over to the left and 6 down, and so on. And just plot those points and connect my graph. So as I look here, I would end up getting this. Now keep in mind, it says we only go up to x being -2, so I can't have my line go past this here, because once I go past to the right, my x value would be larger than -2 here. And it says it only exists to the left of -2. So I have my graph going to the left of -2. And you should realize that this is a line, slope of 1 with a y-intercept -3. And you can see we do have a slope of 1, up 1, over 1, up 1, over 1. And if it did continue on, you could see it would cross at a height of -3. But we don't want it to continue on. We need it to stop here because of our domain says it stops when x gets to be -2. So this is technically a ray. So now, when we look at this one here, I need to try numbers between 1 and -2. Well, you might think that, well, that means I could try 0. 0 squared and take the opposite of that. And I could try -1. -1 squared is a +1. Take the opposite and I get -1. Now you might be thinking, why can I use a -2 when it says only greater than a -2? Well, if I choose -2 and figure out where that is, that's going to tell me where I'm going to have my open circle, meaning it goes up to that point but does not include that point. So if I take a -2 and plug it in, -2 squared is 4, and take the opposite of that, I would end up getting a -4. Same idea on this end. Since there's no equal to here, when I use this point, it'll tell me where to put that open circle. So I come along and I graph these points, -1, -1, 0, 0, and then this tells me where to put my open circle. This tells me where to put my open circle. And so when I come along and connect those points and graph them, it ends up being this shape, which should make sense. You realize that this is a parabola opening downward, and we're looking at a parabola going from -2 up to +1 for our axis. So now, as we take a look at this, you know that this is a line, negative slope, y-intercept being 4, but our domain is only from 1 to infinity. So that means I could try 1, take 1 and plug it in here. -1 plus 4 is this. Take 2, plug it in, the opposite of 2 plus 4. Take 3, plug it in. And I could try 4, or I could try any number I wanted as long as it was greater than or equal to 1. And then I go ahead and I plot my points. Over 1, up 3. Over 2, up 2. And so on, and plot those points. And when I connect those, I end up getting a graph that looks like this. Now, it does appear to be a line, as we were predicting. It does have a slope of -1, over 1, down 1, over 1, down 1. If this line did continue back, you would see it would cross at a height of 4. But keep in mind, this line only exists from 1 and to the right, according to my domain. And this is our piecewise function. Now, your calculator will graph piecewise functions for you. Basically, you got to put each piece right here into a different y equals on your calculator. You put in your function, then hit divide, and then in parentheses, you want to go x and then put the domain. The less than or equal to, the greater than, the and statement, all that stuff is found underneath your test, which I believe is second math on your calculator.